अच्छा, अब इसमें क्या है कि स्टार्टिंग विद द फर्स्ट क्वेश्चन कह रहे हैं कि स्ट्रक्चरल आइसोमर्स खाली ठीक है, यू हैव टू ड्रॉ के C4H8 के कितने होंगे इट्स इन उससे क्या एल्कीन्स और साइक्लिक एल्केन्स दे शुड ऑल बी कंसिडर्ड ठीक है. So C4 right, so you would have to draw all of them के एक तो ये हो गया 4 और double bond could be on the first one or it could be double bond structural उसने कहा no stereo ठीक है, so double bond could be on the second one. फिर क्या हो सकता है, it could be chain. अब chain में that's the only option, no other option right. अच्छा, any other isomer of C4H8 H8 ही होगा ना, it's an alkene, so it's 3 1H 1H 2H's ठीक है, 3 1H 1H और फिर दोबारा 3.
फिर एक साइक्लो एल्केन बना दे.
ठीक है, इसके अलावा तो ब्रांच या चेन या पोजीशन कोई नहीं होगा ना, that's it right.
जी.
Cycloalkane will be a functional group isomer because the functional group is missing in this case, or you have changed it. तो कंफर्म है ये that's ठीक है, that's it I guess. That's it. 1 2 3 4. अच्छा, what if he had included stereo as well, तो फिर कितने होते हैं?
सर दो और हो जाते हैं.
दो और कौन से?
नहीं नहीं, एक और हो जाता. सॉरी, एक सेकंड. एक और हो जाता. ये पहले वाला समझ ले, सिस हो गया, फिर दूसरे ट्रांस हो गया.
मतलब ये वाला होता है ना, this would have been making cis trans right.
जी सर, तो इसको हम फिर
तो
दो
इसको दो
काउंट करेंगे,
दो
तो
काउंट
इसमें
करते हैं.
5.
ठीक है, फिर 5 हो जाता. ऑप्टिकल तो कोई नहीं है ना, ऑप्टिकल कोई भी नहीं है. 4 डिफरेंट ग्रुप्स नहीं, देयर इज नो वन. अच्छा, व्हिच कंपाउंड विल डीकलराइज ब्रोमीन? तो कौन रिएक्ट करता है ब्रोमीन एक्वस के साथ?
जिसके पास डबल बॉन्ड होगा तो सी होगा ना कोई.
ठीक है, हाउ डू यू नो कि C हैज डबल बॉन्ड?
और सी एच है और एक और भी सी एच है, तो
हाँ
कार्बन डबल बॉन्ड होगा.
ठीक है, तो ओनली वे दैट मेक्स सेंस इज कि दे हैव अ डबल बॉन्ड ठीक है, सो C ठीक है. फिर नेक्स्ट वन कि alkenes react with hydrogen bromide. The reaction proceeds by an intermediate carbocation, the most stable. वो मैं खोल लेता हूँ जो समरी किधर है, मैंने भेजी हुई ग्रुप पे ना. अच्छा, उसके बाद समरी में ना यू आल्सो हैव अच्छा यू आल्सो हैव वो रिएक्शन मैकेनिज्म्स भी.
ओके सर.
तो अच्छा, ये कौन सा है? इट्स alkenes वाला ना, carbocation राइट. तो इट्स दिस वन ना, alkenes HBr फॉर्म हो रहा है ना, सिर्फ फॉर्म है halogen alkane ठीक है, इट्स दिस वन HBr ये वाला electrophilic addition. Now so the mechanism is given, it's given below somewhere. This is the mechanism via carbocation intermediate. This is for HBr ठीक है, the HBr H positive goes and bonds, carbocation gets formed, and then you have this reaction. Now the thing is कि कहाँ पे गया? Alkenes react with HBr. The reaction proceeds by an intermediate carbocation. The more stable the intermediate, the faster the reaction. तो firstly वो कह रहा है कि it happens by an intermediate carbocation. तो वो तो ठीक है. The more stable the intermediate. अच्छा, which intermediate carbocation is more stable? उसके बारे में what did we learn about that? कि ठीक है, we learned कि there's an intermediate carbocation that is formed in many mechanisms that is formed. अच्छा, ये साथ ही ना आगे लिखा हुआ है कि दिस इज जो Markovnikov's rule नहीं था, उसके अंदर we stated the carbocation that have more electron donating alkyl chains which decrease charge density on carbocation, making it stable. So if the carbon which has the positive charge is in the middle of the molecule, then that means It's got a lot of alkyl chains, electron donating alkyl chains from all sides, and the positive charge is going to be very small. That makes it very, very stable. ठीक है, clear है ये?
जी सर.
वो स्टेबल क्योंकि याद रखना पॉजिटिव चार्ज जब भी ज्यादा होता है ना, if you have a very high positive charge, it's not stable because it will attract things and it will be very reactive, so it's not going to be stable. Positive charge, if it's less, then it becomes very, very stable, then it's more likely to be formed. अगर पॉजिटिव चार्ज बहुत ज्यादा होगा तो वो फॉर्म ही नहीं होगा, क्योंकि उसको मतलब वो फॉर्म होने लगेगा तो वो पॉजिटिव चार्ज will immediately attract electrons from somewhere, so it would be very hard to form this positive charge which is not surrounded by large groups. अच्छा, anyway, तो इसकी probability कम होती है. अच्छा, but anyways, coming back to the question, the most stable, which sequence correctly shows an increase the speed of the reaction of the alkenes with hydrogen bromide? So first one, ethene, ठीक है? Now ethene is double bonded H. So what is the carbocation intermediate that's going to form? वो HBr में से ना, the H is going to bond with it, and the double bond between them is going to go away because the H took its electrons and the carbon will become positively charged. ठीक है? अच्छा, what type of a carbocation this is? This is a 1 degree or a primary carbocation. Just 1 second. अच्छा, hello.
जी सर.
हाँ. अच्छा, this is a 1 degree carbocation, right? Clear? Is it stable or unstable?
Unstable.
ठीक है, this is unstable. ठीक है, so अच्छा, then you have propene. Now propene is this thing. So अब propene वाला जो case है ना, that's अच्छा, Markovnikov's rule, the H will bond with the carbon that's already bonded to more H atoms, so the double bond will go away, and this will become the carbocation. ठीक है, this is a 2 degree carbocation because it's bonded to 2 carbon chains. Up here you have 2 methyl propene, so that's so 2 methyl propene, so CH3, and you've got H. Now what happens is the double bond is going to go away. H will bond with it, and this is a 3 degree carbocation. The fastest concept, which one is the most stable? That's this is going to be the fastest, right? And this one will be the slowest. Is this clear? Ethanol, fastest speed of the reaction. Most stable, the faster. ठीक है, is this clear? ये clear है?
सर वो फास्टर और स्लोअर वाला मुझे नहीं समझ आया.
नहीं, वो तो उसने खुद कहा था. The more stable the intermediate, the faster the reaction.
ओके सर, ठीक है.
तो मतलब वो stable तो fastest, ठीक है. Slowest क्योंकि ये form ही नहीं होगा ना. It would be very hard to form it क्योंकि what will happen is, well, the reasoning behind that, although he's not asking for the reasoning, already told you that, but the reasoning behind that would be कि a 1 degree carbocation is very hard to form क्योंकि if the HBr, the positive H comes in, so it would be very hard for it to pull electrons away from the double bond. Because ये जो carbon बनेगा ना, that will have a very strong positive charge, so it will be very hard for it to actually pull electrons away from it. Is that clear?
जी सर.
अच्छा, so this is the slowest, that's the fastest. So you've got A answer. A, you know. ठीक है,
जी
Zach?
सर.
So the next one is reaction occurs when a sample of 1 chloropropane is heated on a reflux with sodium hydroxide dissolved in ethanol. Which was correct?
B.
So हाँ, ethanolic NOH, ठीक है. that is B elimination. It forms propene. ठीक है, so वो वही है. It's halogenoalkanes में, I mean this part. If NaOH is ethanolic, it will become an alkene. हाँ, उसमें एक NaOH अगर aqueous होगा, then it will become an alcohol. Then you will have a substitution reaction. In this case, it will be elimination. और प्रोपीन बन जाएगा. ठीक है. अच्छा, again halogenoalkane, they can all be hydrolyzed. Which way is correct? A relative speed of hydrolysis. तो speed में बताओ कि will the bromine halogenoalkane have faster reaction or chlorine halogenoalkane? Who's got a stronger bond? Cl or Br?
Cl.
तो reaction क्या होगा? Fast or slow?
Slow होगा ना, क्योंकि greater electronegativity है.
नहीं, slow होगा because it would be very hard to break the bond.
जी सर, वही कह रहा, slow होगा.
नहीं, इलेक्ट्रोनेगेटिविटी कहाँ से आई है बीच में?
सर यही वो क्लोरीन और कार्बन के दरमियान जो होगा.
हाँ, लेकिन इलेक्ट्रोनेगेटिविटी तो वो है कि it will be a polar bond. ठीक है, बट यहाँ पे तो स्ट्रेंथ की बात हो रही है. अच्छा,
जी सर.
so Q and R, Q will be fast. ठीक है, तो it's either going to be A or B. अच्छा, mechanism. This is कौन सा? This is a primary halogenoalkane. Sorry, this is a tertiary halogenoalkane. This one is a primary, and this one is also a primary. तो अब mechanism. What were the mechanisms of halogenoalkanes? वो भी यहाँ पे given है. Nucleophilic substitution. So halogenoalkanes had two mechanisms. One was your अच्छा, ये जो 4 पेजेस है ना, ये एक्चुअली मतलब मोस्ट ऑफ इट इज जस्ट दिस. वो जो हमने डिटेल में किया ना, that's more like if you really want to go into detail. ठीक है, मतलब 90% of everything is actually covered by this. बाकी तो वो explanation है, वो जो the other notes, ठीक है, वो जो board है ना, that's more like explanation. So primary halogenoalkanes, they have ये वाला reaction mechanism because the OH directly attacks the carbon and bonds to it. Reason being that it's very hard to form a primary carbocation. So carbocations don't, I mean, it's very hard for the Cl to leave because the positive charge over here is so strong that somebody has to push the Cl out. So OH ion has to come in and then the Cl gets pushed out. In a tertiary carbocation, sorry, halogenoalkane, what happens is that it's very easy for the Cl to leave because the carbocation is very stable. It's got a very low charge density. So the Cl can leave easily. The carbon will have a very small positive charge. So इनके बीच में attraction जो होगी ना, it's not going to be that strong. So it would be easily formed. And then the OH can slowly come in. So SN1 and this is SN2. So P is going to be, primary is SN2. R is also SN2. This one tertiary will be SN1. ठीक है, इसमें the OH ion will come in and then the Cl gets knocked out. Over here, what will happen is the Br will first leave and then, one of the reasons why the OH ion cannot come in is because the carbon over here is surrounded by large groups. So it can't even come close to it. So, कौन सा हुआ? This P is SN1A. Is this clear?
जी सर.
So a sample of 2.3 grams of ethanol is mixed with an excess of potassium dichromate 6. The reaction mixture is boiled under reflux for 1 hour. The required organic product is then collected by distillation. The yield of product is 60%. Which mass of product is collected? So a sample of 2.3 grams of ethanol is mixed with an excess of a moles of question. So he's boiling it. So complete oxidation or incomplete oxidation? Aldehyde or carboxylic acid?
अच्छा, carboxylic हो जाएगा.
Because reflux में तो वो bind ही नहीं कर सकता. Reflux is it's trapped inside. ठीक है, so it will form carboxylic acid. So that means your ethanol molecule will actually end up as carboxylic, as a carboxylic acid. ठीक है, that's what will happen. अच्छा, so solve for, how many moles is this? 2.3 grams. How many moles is this? 2.3 divided by the MR, which is 46, I think. कितने moles बने?
.05 हो जाएगा.
Point?
0.05.
So how many moles of the product? That's going to be 0.05 moles as well, right?
जी sir.
And multiplied by the MR, which is 60.
मेरा 3.0.
3.0 grams. Achha, but the yield of the product is 60%. So what is the mass that you're going to get? You're going to get 60% of. Kitna 1.8?
जी sir.
Okay, so the answer for this is 1.8. The structure of tartaric acid is shown. 4 moles of substance X react with 1 mole of tartaric acid. What could be substance X? The 4 moles of substance X. This is tartaric acid. Sodium, how many? This is a carboxylic acid. Sodium will react with carboxylic acid. It will form a salt, right side. This is a carboxylic acid as well. So sodium will react with the carboxylic acid and it will form a. Sodium react करता है alcohol के साथ. I mean, this is an alcohol, ठीक है? These two. So remember, alcohols do react, ठीक है? यहाँ पे. Alcohols, they have a reaction with sodium only. That's it. Alcohols lose H plus ions, but it's almost impossible for them to lose H plus. It's like, I mean, they're then you can't even consider them as acids. So this one, so it will react with, and this one will also react with. So A, ठीक है, 4 sodiums will come and react with it. Is this clear?
जी sir.
ये बाकियों के साथ only the carboxylic acid will react, not the alcohol. I said 2,4-D pH reagent. That's a test for carbonyl compounds. 2,4-D pH. You get an orange precipitate. Yellow precipitate with alkaline aqueous iodine. So alkaline aqueous iodine is the iodoform test. Yeah. Its iodoform test is that you have to have a specific structure in the molecule. You have to have a CH3 next to a carbonyl serial bond O, or R जो है carbon chain है, या फिर H भी हो सकता है. And the other one is you need to have, or it could be a methyl with a CH-OH, exactly this structure, and R could be an H or a carbon chain. So you've got a carbonyl, and it has to give iodoform positive. So first one, ethanol. The ethanol. Ethanol is CH3, CH2, NOH. सही है कि नहीं?
जी सर.
नहीं, क्यों सही है? आइडोफॉर्म टेस्ट इसका पॉजिटिव होगा.
सर वो ऑप्शन के लिए ऐसा नहीं.
जी, नहीं, आइडोफॉर्म टेस्ट पॉजिटिव होगा इसका.
नहीं नो.
नहीं होगा ना. CH3 CHOH है ना साथ ही. That is what the iodoform test. CH3 CH and OH. R जो है, that could be a carbon chain or it could be an H. So I think देखिए ये वैसे confirm कर लेते हैं. For ethanol it's definitely positive. Ethanol के लिए let me just double check. एक second.
But sir, ethanol won't have a positive reaction with 2,4-D and pH.
हाँ नहीं, वो मैं उसमें वो तो मुझे पता है, वो तो इसलिए वैसे ही गलत है ऑप्शन. लेकिन एथेनॉल आयोडोफॉर्म टेस्ट नहीं, लेकिन स्पेसिफिक बता भी देखिए. एथेनॉल हाँ, वो डिस्टिंग्विश कर रहे हैं एथेनॉल और मेथेनॉल को आयोडोफॉर्म टेस्ट से. नहीं, आई जस्ट वांटेड टू इंश्योर के ये जो R था ना, can this be H or not? I mean, the R is often referred to as the carbon chain, but over here the R could be an H as well. ठीक है, is that clear? तो
जी
ठीक
सर।
वो ठीक है, एथेनॉल का टेस्ट पॉजिटिव होगा, आइडोफॉर्म टेस्ट पॉजिटिव होगा, but definitely the iodoform test is not going to work. Oh, sorry, the first one, 214 pH. So ethanol is out of the question. So for all the three, the first one is correct. Methanol jo hoga na, that's just one carbon atom and it's carbonyl, so it's just this. So you don't have the iodoform test is not positive. Propanol ka kya hoga? Propanol is 3 and it's an aldehyde, so you got an H. That's a CH2 and the propanol is not going to have a positive, it's going to have a carbonyl 214 pH positive, but it's not going to be iodoform positive because methyl next to cetyl bond O is not next door. Or finally, you've got propanone, which is uska positive hoga. Dono. And that is going to be the, so that is going to be the answer because you got methyl and next to C double bond. Oh, ठीक है. So is this clear?
जी सर।
अच्छा फिर ये मुझे याद पड़ा, हमने किया नहीं था
किया था सर।
ये वाला, किया था ना, इससे आगे वाले हमने किए थे, नहीं हम नहीं किए थे।
तो कॉन्सेप्ट ही मैं कह रहा था किया था। ओके
हाँ
सर, मैं कह रहा हूँ कॉन्सेप्ट वगैरह किया था इसका। ओके सर।
नहीं, लेकिन ये वाला जो था, आई रिमेम्बर डूइंग दिस क्वेश्चन, पर ये अगला वाला तो डेफिनेटली हमने नहीं किया हुआ, नॉन साइक्लिक alkane that is a calcinator, ठीक है। So let's do this one. Which reaction will give the product shown? He's saying a student suggests two uses of LiLH4. Alkenes, this is not going to happen. This will happen. Alkenes have no reaction with LiLH4. But carboxylic acids they do. ठीक है, carboxylic acid जो है ना वो वापस they get reduced by, like if you look over here, so your carboxylic acid will get reduced to aldehyde and further get reduced to a primary alcohol. So carboxylic acids they get reduced. Which reactions would give the product shown? So I guess just the second one. So C is the answer. As the next one is compound X contains a single ester group. X contains 26.7% by mass of oxygen. Which pure product could be produced by the hydrolysis of X? So problem is that you have to kind of do each one of them, or मतलब तो बारी बारी बहुत लंबा क्वेश्चन हो जाएगा if you do one by one. That's going to take a very long time. What could be the other way around it? 26. Ester, is there a general formula for an ester? It's the general formula of an ester is the same as a carboxylic acid. तो O2 होता है. I'm just thinking if I want to, like, instead of solving it one by one, if I want to solve it all of it together. So 27.6%, right? So mass of oxygen divided by the total, right? So mass of oxygen is 32 and the total is what? 12 into 9, 12 into n, plus 32 plus there are 2n hydrogens plus 2n. And this should come out to be what? 27.6%, which is 0.276. इसको जरा इधर शायद उससे भी लंबा मेथड हो जाए. 32 is equal to 0.276 times 12 n plus 32 times 0.276 plus 2n times 0.276, यानी इसको करना है इसको तो सॉल्व करना क्या आता है? 32 minus 0.276 times 32 and divide by 12 into 0.276 plus 2 into 0.276. क्या आंसर है? What did you get for N?
Six है सर.
6 है?
जी सर 5.9958 आ रहे तो 6 ही करें.
5 point कितना? 996. अच्छा ठीक है 6. So that means it's going to be, what's the answer? It's going to be A, right? वो वैसे कर लेते तो आई जाता. मतलब you make the ester butanol and ethanoic acid and then it's so just remember that esters have this general formula which is I mean only is general formulas don't usually work because it could have a double bond as well, but these simple esters then I mean I guess there's no double bond. They were not, I mean the carboxylic acid was not a complicated carboxylic acid, तो जनरल फॉर्मूला काम कर जाना था. But is this clear? Question clear?
जी सर.
Or 6, right? 2 either and 4 from the other side, right? This is 7 carbon atoms. This is 2 carbon atoms. This one is वो उसी तरह. That's the next one. What is the least number of carbon atoms in a non-cyclic alkene molecule that has a chiral center? Yeah, interesting question. Can you try and solve this? Okay, what is the least? You want to make a non-cyclic alkane. Non-cyclic alkane का मतलब है normal alkane, like no cyclic structure, right? The non-cyclic को छोड़ दो. You just have to make an alkane. The alkane should be chiral. So what is the least number of carbon atoms that you need to do that?
7.
7 किस तरह के? So basically, I want to make a carbon atom that's chiral, right? All 4 groups must be different, right? So or alkane, it has to be an alkane. So you got an H. तो यहाँ पे क्या होगा फिर दूसरी? What can I have over here?
C3.
ठीक है, minimum. So minimum is I'll have 1 carbon atom on this side. So now I have to make the other side different. So there's going to be, and now I have to make the fourth side also different. So I will have 3 carbon atoms on that side. Okay. So 7 बन रहे 3 3 6 7 हो गया. हाँ ठीक है. Is this clear?
जी सर.
So then we have which monomer could produce this polymer by addition polymerization? So what's the repeat unit of over here? अच्छा ये थोड़ा सा देख लो कि look at the repeat unit. It's remember the monomers can join upside down. I mean Cl could be pointing downwards. The Cl in the other one could be flipped around. ठीक है, the Cl is point, but they're all kind of the same monomer. Is that clear?
जी सर. तो ऑप्शन बी.
तो option B है. ठीक है, it's the same exact monomer, just connected upside down. Well, you're not used to it. ठीक है, olers में they were always connected in the same exact orderly manner, right? तो वो उल्टा होकर भी connect हो सकता है. ठीक है, is this clear?
जी सर.
Or compound by acidity with the mild oxidizing agent, one of the products of the reaction with hydrogen cyanide forming 2-hydroxy. It's treated with a mild oxidizing agent. Ab alcohols, so we just know one oxidation reaction. So what happens to all these alcohols, butanol? That's a primary butanol, primary or secondary? What is this? Or tertiary?
Primary.
तो इसने ऑक्साइड होके क्या बना है? प्राइमरी ने. It's going to turn into a carboxylic aldehyde, it's going to turn into a carboxylic acid eventually. Achha, butyren 2-ol. Butyren 2-ol is, that's a secondary alcohol, right? So secondary alcohols, they turn into ketones. सही है?
जी सर.
अच्छा, फिर propan 1-ol. Propan 1-ol is again primary. So it will turn into a carboxylic acid. Or propan 2-ol, that will eventually turn into a ketone. ठीक है, तो ये सारा हो गया. But then he says the reaction is, he does a reaction with HCN. So HCN के साथ कौन सा reaction होता है? ये पहला, the first page पे ना, nucleophilic addition. Aldehyde and ketones, they undergo this reaction. The double bond O, it turns into an OH back again, but the CN gets attached at the bottom. Okay, that is what the reaction nucleophilic addition is. So there's going to be, so in each case, what will happen is, okay, the CN will get attached to this positive carbon atom, और ये ऊपर वाला ना OH बन जाएगा, ठीक है? तो OH and the CN gets attached to it. I mean, the double bond goes away. CN gets attached to this, and this becomes OH, and this becomes OH. Double bond goes away. Okay, so I'm going to, so I'm going to remove all the double bonds. So which one is 2-hydroxybutene-nitrile?
This one. This
कौन सा? 2-hydroxy butene nitrile. नहीं, ये तो नहीं है.
एक सेकंड.
ये इसलिए नहीं है कि इसमें 2-methyl भी आ गया ना. That's, I mean, look at it. It's हाँ, ये नहीं है. ये नहीं है. मैं बता दूं ये क्या है. What's the name of this molecule? ठीक है, the name of this molecule is, this is the longest chain, so that's butene nitrile. It is definitely 2-hydroxy, but it's also 2-methyl as well. There's a methyl branch as well. Is that clear? तो बताओ कौन सा है?
एक सेकंड. सर एक ही ऑब्वियस रहता है, लेकिन वो मुझे समझ नहीं आ रहा कि वो उससे 2-हाइड्रोक्सी क्यों कहेंगे हम.
इस वाले को
सर पहले वाले. उसी के पास 4 कार्बन एटम्स हैं. अच्छा नहीं, और भी
उसके पास जो longest chain है, that's this one. Okay, it's
और
actually 5
ठीक है.
carbon. So this is pentane nitrile, and this is also 2-hydroxy. ये OH एक और क्यों आ गया था यहाँ पे? इसमें 2 OH क्यों, क्या कर रहे हैं? अच्छा, इसका तो रिएक्शन ही नहीं हो रहा था. ये तो कार्बोक्सिलिक एसिड था. तो ये तो वैसे ही out of the question. Carboxylic, it used to be a carboxylic acid. Carboxylic acids don't undergo any HCN reaction. ठीक है?
ओके सर. सर तो बस आखिरी यही रह गया, लेकिन इसमें डाईहाइड्रोक्सी हो जाएगा.
नहीं, वही मैं इसका सोच रहा हूँ कि why is there propan 1-ol turns into, अच्छा, problem ये one of the product reaction. So I guess he's going with यही होगा answer. But I think उससे ना, he did not tell us के whether the oxidation was complete or not. It could have been an incomplete oxidation. अगर incomplete oxidation होती ना, तो it would have been an aldehyde. मतलब वो start में ना, it would have been, instead of a carboxylic acid, it probably would be an aldehyde, right? हो सकता है ना, उससे conditions बताई नहीं exactly, तो हमने we wrote carboxylic acid, so maybe it's not carboxylic acid. तो फिर CN होता, और फिर that would have been formed, that would have formed OH. The longest chain, that would be butene nitrile, and it's 2-hydroxy. ठीक है?
ओके सर.
क्योंकि और तो कोई ऑप्शन नहीं है ना. इसमें भी मिथाइल की चेन आ जाएगी दिस वन, because if you look at the longest chain it's going to be, there's going to be a carbon branch. तो फिर यही रह जाता है, that's the only option. दूसरे का one of the products, ठीक है. So I guess this is not complete oxidation. ठीक है, clear है ये?
जी सर.
तो चले ठीक है. ये आखिरी भी देख लो स्ट्रक्चर ऑफ ये व्हाट इज द गेन और लॉस ऑफ हाइड्रोजन एटम्स पर मॉलिक्यूल, किसके लिए? अच्छा, दिस इज कन्वर्टेड इनटू दिस. तो बैठ के फिगर आउट करो हाउ मेनी हाइड्रोजन्स आर लॉस्ट और गेन्ड. वो ये बड़ा मुश्किल क्वेश्चन है. मतलब it's I mean it's an easy question but it's just even at the end you'll probably get it wrong. ये बैठ के सोचो अब बैठ के कि अच्छा दिस थिंग डबल, ये यहां से लेके यहां तक I guess nothing is changing, right? Or is something changing? The middle part.
नहीं सर, कोई चेंजेस नहीं है.
ठीक है, it looks ठीक है. No changes. तो changes फिर कहाँ पे है? It's on this side, right? So you have to figure out how many H's are lost when this change happens. वो कर लेते हैं, काउंट कर लेते हैं, ठीक है. This is 2 H's, 2 H's, 1 H. बाकी H's मतलब कोई H छुपा हुआ तो नहीं है. I think there's 1 H over here as well, right? These carbons all have the same H. ठीक है, मैं सारे ड्रॉ कर लिया. That's 3 3 3 9 9 plus 10 11 12 13 14 15 15 H's, right? यहाँ पे कितने हैं?
जी
1 2 3 4 5 6 के H's पूरे पूरे पूरे, ठीक है. So how many do you have? 3 3 3 9 6 7 9 10 11 12 13 14 15. यहाँ भी 15 है. उधर भी exactly same है ना. It's the same exact thing that's happening over here.
probably सर.
So I'll go with no change. मतलब वो कर लो खुद ही हिसाब, यहाँ पे कर लो. I think there's no change happening. ठीक है, is that clear?
जी सर.
लेकिन चेक कर लेना, मैं इधर देखना पड़ेगा. जस्ट काउंट है, ठीक है. आखिरी भी कर लेते हैं which is that's infinite, ठीक है, उसको छोड़ दो. ये actually we only left with this thing, ठीक है. ये जो आखिरी, you always get this one question at the end, ठीक है, infinite. तो इजी है वो, उसमें इतना मुश्किल नहीं है. चले ठीक है. ओके एवरीवन,
अल्लाह हाफिज़.
अल्लाह हाफिज.